Good morning, everyone. Mrs.E.Srividhya, Assistant Professor, Department of Computer Science and Engineering, Bharat Institute of Higher Education and Research. The course name I have taken is Functional Programming. In Functional Programming, I am going to explain the functions in Haskell. So, functions play an important role in Haskell because Haskell is a functional programming language we all know. Like other languages, Haskell does have its own function definition and declaration. Function declaration consists of function name and its argument list along with its output. Function definition is where you actually define a function. Let us take a small example of add function to understand this concept in detail. So this is an example of addition of two numbers. So before going for a function definition in Haskell, we have to know how we have to declare a function. So function name we have to mention, that is a user defined function name we have to give, and then you have to mention the input output of the data type. So what is the input you are going to give, that is in the form of which data type, and then output which is in the form of which data type we have to mention. Okay, so here this example is an addition of two numbers. So we are going to give two input and one output we are going to get. So add is the user defined function name we have to mention, and then we have to specify double colon and integer, and then another integer because two input we are going to give. That's why we are giving two integer, and the next one integer. It's a function declaration. And then now we are going for function definition. So here add x, y equal to x plus y. So here we are going to add the two values and we are going to save it here. And then main equal to do. And then put strlen, the addition of two numbers is. And then function declaration over, function definition over. We have to call the function, right? So here the print statement we are going to call the function. So print add 2 space 5. So this 2 and 5 are the parameters of the add function. Okay. So for two values, two input real, right? So that one 2 and 5 we are giving here. And then you will get the output addition of two numbers is 7. So here we have declared our function in the first line, and in the second line we have written our actual function that will take two arguments and produce one integer type output. Like most other languages, Haskell starts compiling the code from the main method. Our code will generate the following output. The addition of two numbers is 7. Next one, pattern matching. So pattern matching is the process of matching specific type of operation expressions. It is nothing but a technique to simplify our code. This technique can be implemented into any type of type class. If else can be used as an alternate option of pattern matching. Pattern matching can be considered as a variant of dynamic polymorphism, where at runtime, different methods can be executed depending on their argument list. Take a look at the following code block. Here we have used the technique of pattern matching to calculate the factorial of a number. So this is an example for pattern matching. Here we are going to specify the user defined function fact double colon we have to give, and then one input I am going to give, and then one output I am going to get. So that input and output are in the form of integer data type, that is int data type. And then fact 0 equal to 1. So 0 factorial we already know, that is 1. So you can write fact of 0 equal to 1, and then fact n. So other than 0, that one will come under here and you will perform this one. Fact n equal to n into fact of n minus 1. And then main equal to do. That next line we have to give some space, and then we have to start put strlen, the factorial of 5 is, and then we have to print fact of 5. Okay, so factorial of 5 is 120. So we all know how to calculate the factorial of a number. The compiler will start searching for a function called fact with an argument. If the argument is not equal to 0, then the number will keep on calling the same function with less than 1. Okay, so that of actual argument. When the pattern of argument exactly matches with 0, it will call our pattern, which is fact 0 equal to 1. So our output code will produce the following output. Factorial of 5 is 120. Next one, gods. So God is a concept that is very similar to pattern matching. Both God and pattern matching are similar only. Because here instead of writing that condition, you can use that pipe symbol. Okay. In pattern matching, we usually match one or more expressions, but we use gods to test some property of an expression. Although it is advisable to use pattern matching over gods. But from a developer's perspective, God is more readable and simple. For first-time user, God can look very similar to if-else statement, but they are functionally different. In the following code, we have modified our factorial program by using the concept of gods. So this is the example for God. That is fact is a user-defined function name, double colon, and then integer. So one input, one output, that data type I mentioned here. And then fact n. And then after fact n, you have to give some space and you have to start. This is a pipe symbol, n equal to 0. If n equal to 0 means you will get value 1. That is 0 factorial is 1. Here we are going to do. N not equal to. If I use backslash equal to means that is not equal to. N not equal to 0 equal to n into fact of n minus 1. And then main equal to 2. Put strln, the factorial of 5 is. So factorial of 5 is that one it will calculate using this calling function calling print fact 5. Okay. So here we are calling the function. Here we have declared two gods separated by pipe symbol and the fact function from main. Internally, the compiler will work in the same manner as in the case of pattern matching to yield the following output. The factorial of 5 is 120. Next one, var class. Now we are going to use a var class. Okay. Instead of writing a big program or big codes, we can use this var class to divide each and all the lines separately. Okay. Var is a keyword or inbuilt function that can be used at the runtime to generate a desired output. It can be very useful when function calculation becomes complex. Consider a scenario where your input is a complex expression with multiple parameters. In such cases, you can break the entire expression into smaller parts using the var class. So this is the example for var class. Here we are going to use a complex operation. Okay. So example, roots, user-defined function, double colon. Here we are going to give three inputs, float, everything will be in the float form only. And then you are going to get two outputs that also in float data type. Roots a comma b comma c equal to x1 comma x2 where. So this is the input you are going to give. A, B, C are the input you are going to give. X1 and X2 are the output you are going to get. Okay, where we have to calculate that one X1 and X2, right? So that one we have to mention separately. X1 equal to E plus SQRT of D. So E means we have to use minus B. Okay, minus B divided by 2 into A. And then SQRT of D. D means D equal to B square minus 4AC. That is the formula. We are going to use that one. And then B divided by 2 into A. Okay. Instead of writing everything in a single line, you can split and you can write like this. Okay. And then main equal to do, put strln, the roots of our polynomial equation are print. So function declaration over, function definition over. After that, we have to call the function. So in the print statement, roots of within bracket, I am passing the values for A, B, C. So 1 comma minus 8 comma 6, I am passing the value. Okay, and then I am getting the output in this form. Notice the complexity of our expression. To calculate the roots of the given polynomial function. It is quite complex. Means we are breaking the expression using the where clause. The above piece of code will generate the following output. The roots of our polynomial equation are 7.16 like that, and then another value 0.8377. Next one, recursion function. So recursion is a situation where a function calls itself repeatedly. Haskell does not provide any facility of looping any expression for more than once. Instead, Haskell wants you to break your entire functionality into a collection of different functions and use recursion technique to implement your functionality. So this is an example for recursion function. Fact double colon int int. So one is the input, one is the output. Okay, everything is in the form of data type, integer data type. Fact 0 equal to 1. So 0 factorial is 1. Fact of n equal to n into fact of n minus 1. Main equal to do. Put strln. The factorial of 5 is print of fact 5. So it will produce the following output. Factorial of 5 is 120. And the next one, higher order function. So higher order functions are a unique feature of Haskell where you can use a function as an input or output argument. Although it is a virtual concept, but in the real world program, every function that we define in Haskell use higher order mechanism to provide output. If you get a chance to look into the library function of Haskell, then you will find that most of the library functions have been written in higher order manner. So this is the example for higher order function. Example, import data.car. So data is one of the file in the Haskell, and then import, preload, hiding of map. Okay, and then this is another file. So here we are using map function, map double colon, and then we are going to give mapping the values. So A to B, and then it will be splitted as a separate list format. Okay, and then map underscore empty empty list we have to give equal to empty list, and then map function of x is to abc. We are giving like this means you will get a function x colon map function abc, and then in the main function what I am going to do means I am going to convert the character into an uppercase. Okay, uppercase letters. So print $map to upper tutorial points.com. So it will be automatically converted to uppercase. So in the above example, we have used the toUpper function of the type class char to convert our input into uppercase. Here the method map is taking a function as an argument and returning the required output. Here is the output tutorialpoints.com, everything mentioned in the capital letter. And the next one, lambda expression. We sometimes have to write a function that is going to be used only once throughout the entire lifespan of an application. To deal with this kind of situation, Haskell developers use another anonymous block known as lambda expression or lambda function. So a function without having a function is called a lambda function. Function without having a definition is called a lambda function. Lambda function is denoted by backslash character. Let us take the following example where we will increase the input value by 1 without creating any function. So this is the example for the lambda function. So main equal to do, put strln, the successor of 4 is, and then instead of writing that function you can use that symbol backslash print backslash x of x tends to x plus 1 within bracket I am giving 4. Here we have created an anonymous function which does not have a name. It takes the integer 4 as an argument and prints the output value. We are basically operating one function without even declaring it properly. That's the beauty of lambda expression. Our lambda expression will produce the following output. The successor of 4 is 5, like that it will give. And then function composition. Function composition is the process of using the output of one function as the input of another function. So in function composition, we are going to take the output of one function as the input for this function. So it will be better if we learn the mathematics behind composition. So in mathematics, composition is denoted by f of g of x, where g of is a function and its output is used as an input of another function, that is f. And then function composition can be implemented using any two functions provided the output type of one function matches with the input of second function. We use the dot operator to implement function composition in Asst. Take a look at the following example. Here we have used function composition to calculate whether an input number is an even or odd. Even number double colon int boolean. So here the integer input will be in the form of int and the output is in the form of boolean. So not to boolean. So that is the input and then you get the output string. Even number x equal to if x remain remainder of 2 equal to 0, then true, else false. Not to x equal to if x equal to true. So we are going to check the condition, then this is an even number, else this is an odd number. Main equal to true, put strln example of Haskell function composition and then print not to dot even number of 16. So here we are having two function, that is even number and not two. So for both the function, first one we are going to take the even number value. So even number is the first function we are going to give, that is g of x. And then for the even number output will be treated as an input for the not to function. Okay. So here we are going to take that values and we are going to perform. So first even number it will check, 16 is an even number. So you will get the boolean value, that is true. After that you will write the string, that is this is an even number. So here in the main function we are calling two functions not to and even number simultaneously. The compiler will first call the function even number with 16 as an argument. Thereafter the compiler will use the output of the even number method as an input of not to method. Its output would be as follows. Example of Haskell function composition. This is an even number. Module can, next one, module. So module can be used as a collection of similar or related types of functions. You can import a function from one module into another module. All the import statements should come first before you start defining other functions. Okay. So first one is a list module. List module provides some wonderful functions to work with the list type data. Once you import the list module, you have a wide range of functions at your disposal. In the following example, we have used some important functions available under the list module. So this is the example for list module, import data.list. So this is the file you are going to import here, data.list. So all the functions that are going to use in this will be there in the data.list. Main equal to do. You can directly use it in your program. Okay. strln different methods of list module. And the next one, print integer dot and then tutorialpoints.com. So this will be the interspace means it will take the string tutorialpoints.com and each and every letter will be separated with dot and then intercalculate double quotes. So what it will do means it will take all the list values as a single value and then it will treat as a single string. Let us start with Haskell, right? So this one will be treated as a single string. And then print split at 7. So split at 7 means this Haskell tutorial will be split at 0.7 and it will be separated. Okay, and then print sort. So sort means this is in some order. So we are going to sort it in the ascending order. So here we have many functions without even defining them. That is because these functions are available in the list module. After importing the list module, the Haskell compiler made all these functions available in the global namespace. Hence, we can use these functions. Our code will yield the following output: different methods of list module, and then tutorial points.com will be separated with a dot, and then let us start with Haskell. Separate word will be combined and you will get a new string, and then Haskell tutorial that will be separated with 7 and index value 7. It will be separated, and then that sort method will sort the values in the ascending order. Next one, char module. So the char module has plenty of predefined functions to work with the character type. Take a look at the following code. So import data.char. So in data.char, all the operations about the character will be there. So you can directly use it in your program by using import method. Okay, main equal to true, put strlen, within bracket you can give different methods of char module, and then print to upper A. So this small letter A will be changed to capital letter, and then print words letter steady to right. Okay, so it will be splitted as a single word because this one is a single string, right? That one will be separated and you will get separate words. And then print to lower. So A is a capital letter, so that one will be changed to small letter. So see here the functions to upper and to lower are already defined inside the char module. It will produce the following output: the different methods of char module, capital A. So that small a will be changed to capital A. Letter steady to night will be separated with a single word, and then capital A will be changed to small a. And the next one, map module. So map is an unsorted value-added pair type data type. It is widely used module with many useful functions. The following example shows how you can use a predefined function available in the map module. So import data.map. So this is the predefined file in the Haskell, and then import qualified data.map as map required for GHCL. Okay. So another method. So two modules you are going to import in your program, and then my map is a user defined function name, double colon, integer is the input I am going to give, and then I am going to get map integer within square bracket integer. So this is the output I am going to get. Okay, I'm going to get the integer only, but that integer will be in the form of list. Okay, and then my map n equal. So this is the function declaration, and this is a function definition, and this is a function call. Okay, my map n equal to map dot from list map make pair. So we have to make it as a pair. Okay, how means one double dot n. One double dot n means it will take n values. Okay, so n we have to define, where make pair x equal to x comma within square bracket you have to mention the x. Then main equal to print my map of 3. Only 3 values you can take. That like that. So 1 comma square bracket 1, 2 comma square bracket 2, and 3 comma square bracket 3. Next one, set module. So the set module has some very useful predefined functions to manipulate mathematical data. The set is implemented as a binary tree, so all the elements in the set must be unique. So in the set, if you are using set module means no repetition will be there. Only value will be repeated only once. Okay, that is the meaning of set in mathematics. Right? The same concept will be followed in here as well. So import qualified data.set as set. So this is the file you are going to import in your program. And then text1 equal to hey buddy, and then text2 equal to this tutorial is for Ascal. Main equal to do, let set1 equal to set dot from list text1, and then let set2 equal to set dot from list text2. Okay, and then print set1, print set2. So this HEYBUDDY. So here double D is there, double Y is there. So everything will be removed, and HEBUDY, like that, single words only, single letter only, it will be displayed. And then in this tutorial is for Ascal also, we are having so many letters repeating, right? Only the single value only it will take, and you will get the output like this. So here we are modifying a string into a set. It will produce the following output. Observe that the output set has no repetition of characters. Okay, and the next one, custom module. So whereas in the custom module, we are going to create two Haskell files. Okay, to implement this custom module, we will create a separate file called custom.hs. Okay, along with our main.hs. So we are having two files, custom.hs, main.hs. So in custom.hs, we are going to create two functions, module custom. So this is a module we are going to create. Module custom show even comma show boolean. Okay, show even comma show boolean are the two functions we are going to use. Where. So where means we are going to separate that function as a separate single function. Where show even double colon, input of that one is integer, output of that function is boolean, and the function declaration that one. Then show even x equal to do. If x remainder 2 equal to 0, then true, else false. Okay, and then another function show boolean double colon, boolean will be converted, and that is boolean is input, integer as the output. So show boolean c equal to do. If c equal to true, then 1, else 0. And then we are having main.hs. In this we have to use import custom. We have to use only import custom, not custom.hs. Okay. So if we are going to import any file name, you can directly use the file name. No need of that extension. Okay. Main equal to do, print show even 4. Okay, and then print show boolean true. Okay, our code will generate the following output, true and 1. So it will be an even number, so you will get the output as true, and then if it is true means you will get the integer value, that is number 1. Okay, thank you.